In this example, I'll show you how we apply nodal analysis to a circuit that contains not only a voltage source in here, but also a dependent voltage source. It's a current controlled voltage source. The steps are as usual. What we need to do is we need to identify the essential nodes. I believe this is an essential node, this is another essential node, and this one here is an essential node. The other nodes are just simple nodes. This is just simple node. This is one node, simple node. Okay. Then you can choose any of them to be a reference node. I will choose this one here to be my reference node. And then I will just call this one here as VA, and this I'll call as VB. And based on that, we'll figure out what we need to write two equations with two unknowns in order for us to figure out the currents and voltages across the circuit. However, because we have a dependent current source now, what happens is we're going to have what we call a constraint equation. So there's a little bit of an equation that will appear that contains I phi, and we're going to have to get rid of the I phi. So let me show you what I mean. All right, we'll start with node A. So I will write KCL at node A. So KCL at node A. So KCL at node A is simply, I will start with this current in here. So that will be VA minus, well, the voltage here is 20 volts above the reference. So it is just simply VA minus 20 divided by 2. Okay, remember that's basically the current. So this is an equation for our current, VA minus the 20 divided by the resistance, which gives me the current, leaving that VA, plus I have the other one in here, actually the current going through the 20 ohm, it's simply VA divided by 20, plus, which is pretty much my I phi in here, okay? But anyway, I'm not going to write it I phi because I want to write an equation in terms of VA and VB because that's my ultimate goal. So I'll write it, and that will be simply VA minus VB divided by 5, because this is the voltage in here minus the voltage in here divided by that 5 in here. That's what Ohm's law tells me. I will highlight it, and you'll see now why in a minute. Okay, so we're going to do this here, and that simply equals 0. We'll clean it up a little bit. We'll say, well, 1/2 plus 1 divided by 20 plus 1 divided by 5, and that's basically VA minus V1 divided by 5 VB, and that should be equals to 20 divided by 2, which is just simply 10. So I'll clean it up a little bit, and that should give me, I believe it should give me 15 VA minus 4 V2 equals 200. Pretty much if you multiply both sides by 20, you'll get this particular answer. So let me just highlight this. This is the first equation that has, I believe it's like I wrote it V2, but it shouldn't be V2, it should be VB in here. All right, so let me just do that. And we have that. And that's my first equation, okay? All right, we'll go back in here, and we're gonna say, well, we're gonna write another KCL equation at B. So this is the KCL at node B. So we're going to take a look in here. Okay, we're going to start by the opposite of I phi. Okay, the one that I highlighted is pretty much the opposite of it, meaning it's VB minus VA divided by 5 plus the current going through that 5 ohms in here. So that's simply VB divided by 10 plus, well, what do we do with this one in here? Well, guess what? It's the voltage here minus the voltage in here. So let me just write it in here. So that's VB minus, well, minus what? What's the voltage in here? Do I know it? Well, I do know it. It's just simply I phi. This is actually a voltage source. It's very similar to the 20, but instead of having it to be 20 volts in here or whatnot, I have it as an equation. So all I have to do is just write this equation in here. I'm just going to write it for you in a different color. So this is 8 I phi or phi. Okay, and then what do? We divide it by 2 because that's based on Ohm's law. Okay, of course we can clean up this equation a little bit, but we have now introduced an I phi, which is a current, and these are just voltages. What I need to do is I need to replace this I phi because I have this constraint in here with its value using just the voltages. So we'll take a look in here, and we'll say that the I phi is that. And based on basic Ohm's law, it's just simply VA minus VB divided by 5. This is actually what I highlighted in here, and that's why I highlighted it. So let me just write this in here. So what we know about I phi is just simply VA minus VB divided by 5. That's what we know about it, because it is this voltage minus this voltage divided by 5. Okay, so what I'm going to do is I'm going to substitute this in here, and I'll end up with an equation that only contains VA and VB. This here is what we call the constraint equation. Okay, this is here is a constraint equation. because it constrained that, or because it's coming from the dependent source. Okay, so we'll do that in here. So that becomes VB minus VA divided by 5 plus VB divided by 10 plus VB, let me just do that here, VB divided by 2, and then minus 8 divided by 2, which is 4, okay, times VA minus VB divided by 5, and that should here equal 0. Okay, we clean up this equation a little bit, and we'll end up with the following. I believe it will be negative 10 VA plus 16 V2 or VB equals 0. Let me just clean it up a little bit here. So that is in here. This is here is a VA, and this one here is VB, and that should be equal to 0. And you can take a look in here. Of course, it's equal to 0 because I have no other values. Okay, so we'll highlight this one here, and we say this is basically my second equation. So now what I have is two equations, two unknowns. All I have to do is just figure out and solve them. By solving them, I basically figured out the circuit. And by solving these two equations, you'll figure out that VA is just simply 16 volts, and VB is just simply 10 volts. You could write them in here. So that's 16 and 10. So this one here is 16 volts. And this one here is just simply, what did I say? 10 volts. Okay, 10 volts. Okay. And we can figure out all the currents. For example, if I wanted the I-phi, well, I-phi is simply here. We can just say, well, I-phi is just simply 16 minus 10 divided by 5. And that's basically 6 divided by 5 amps. That's what it is. You can figure out all the other currents. What about this current in here? Let me just hide it in that. We can figure out what this current in here. Let's call it I2. Well, I2 is just simply VB, which is 10 minus 8 I-phi, which I just computed, which is 6 divided by 5, divided by 2. And that will be the current. Okay, again, what this here comes in is the following. I have 10 volts in here, and I have 8 I-phi in here. But I know that the I-phi is 6 divided by 5 because I just computed it. So 8 times 6 divided by 5, that's what I have. That's the value of the voltage in here. That's 8 times 6 divided by 5. Okay, and of course we divided by 2 because based on Ohm's law, and you compute what that value is and you figure out what that current is.